All right, Suzuki Coupling. The Suzuki Coupling is similar to the steel. Can I say a word about coupling before we begin? What do we mean by coupling? It means putting two things together, right? So if I'm going to couple a square and a circle, what I'm going to do is I'm going to make that. They've been coupled, all right? So that's what we're going to do. We're going to couple things. We're going to come down here. We're going to couple, where's my pen? Right here. We're going to couple R and a different alkyl group, and we're going to make that. We're making a carbon-carbon bond, a carbon-carbon bond. And that's it. That's what we're doing. Now, we have to get into the details, but that's what we're doing. And it's very important that you can appreciate that by the time we're done. Excuse me. When I say appreciate, I don't mean like it, right? I just mean, I mean grasp, understand. That's what we're doing. We're making a carbon-carbon bond. So here's how we're going to do it. Skip this. Here's how we're going to do it. We're going to take a boron and two Ys. We'll say what Y is in a minute, okay? We're going to take a boron, two Ys, and we're going to put an alkyl group or an aryl group or a vinyl group or an allyl group on it, and we're going to couple it to another alkyl or aryl or vinyl or allyl. Right? Notice I did not say acyl. You might want to pause the video for a sec right now. If those are unfamiliar to you, pause it. Go look those up. You've seen them many times, but we have to use them now. Okay, so that's what these guys are. It's one of those four. And I know that because I read the book. That's how I know. It's there, and I don't know what page, but it's there. I should go get my book. So again, I looked at all those groups, and I saw all four of those groups in there. All right. Now, a base is also used in the reaction. So these are the reaction conditions. You should memorize these. I think I'm sounding a little pedantic today, aren't I? I'm sorry. I heard myself, and I said that doesn't sound nice, but that's okay. I'll try to fix it. So this is what we're dealing with. We're coupling two things, R and R prime, and those two things are one of these four, not this. And we're going to use these details, right? Pladmium, triphenylphosphine, I guess that's tetra, right? Look at that. Tetra, triphenylphosphine. Probably it's like platinum 4, triphenylphosphine. And I wouldn't even worry about saying it, right? You only say it if it's going to help you remember it. So PD, PPH3, 4, right? Okay. And then sodium methoxide, and you definitely should know what this is, right? Because we've used that many times. All right, we're going to make that, and we don't care about this. We never care about that. So it's always the carbon. It's always the organic thing we're trying to make because we are studying here. I'm sounding this way again. We're studying organic chemistry, right? And so Klein and every other author and your professors will oftentimes not even talk about that stuff over there. So don't worry about it. All right. Y groups. Now, all right, let's talk about the details now. Details. What are these guys? Well, Y groups are usually alkyls, alkoxys, or hydroxyls, right? That's what they usually are, and we'll see some examples as we come along. And as far as you're concerned, though, when you're looking at this stuff, you're looking for an alkyl, an aryl, or an allyl, right? Something over here that could be R, and you're going to clip it off. I hear it in my voice. It just sounds edgy. I'm really sorry. I'm going to try to be sweet here. Come with me, friend. You are you are going to look for a boron, clip something off of it, look for a halide, clip something off of it, right, and tape them together. That's what you're doing here. All right, let's do it now. So here's an example. Suppose that you find your boron. You see two alkoxies, right? You see two alkoxies. You find something else. What's this? Well, I don't know, but it's not a boron. Let's assume that that's my halide. Okay? And we'll look that up in a little bit. But we got this weird thing here. Let's assume it's a halide. But you see it's not a boron, right? So now here's your vinyl group. And here's your aryl group. Look at that. And I clip them off. And I tape them together. There's my aryl. And here's my vinyl. Alright, that's what we're doing. And that's all we're doing. So here's my alkyl, because I found the boron, right? Got to find the boron first. Clip off the alkyl. Get ready to tape it back onto something else. Find the halogen, which is, I guess this wasn't a halogen, right? But it's something like a halogen. I mean, it's not boron, right? Okay. Clip off the aryl. Do you see that? Look at that. And just tape it on there. And skip this stuff. Alright. Oh, in this case, we've got a couple alkyl groups on here. Alright. My bride just texted me. Thank you, sweetheart. Alright. So, look at that. Oh, in this case, we're given Y's. Weird Y's. Oh, and they're given little parentheses down here. And I'm not being sarcastic when I say this. It doesn't matter. Right? Just find your boron. And if you've got Y's on there, you know that that's not the alkyl you're looking for. Alright. Now, I suggest, as always, that you, first of all, pause the video now. Make up what you think is the simplest possible version here of this question. Oh, look at this. Look at this. This is also scary. PD catalyst. And I made a little bit of joke about me being edgy this morning, but I'm not being sarcastic now. Look at this. PD catalyst. PD catalyst. You see it? It's a palladium catalyst, and you got to go. Okay, I've never seen it written like that, but I know it's a palladium, and I know it's working as a catalyst, and I know I have a base. Right? So, all right. Let's first of all assume it's going to be exactly like this, and make up our own question. Go do that. Make up your. Pause the video. I'm gonna make up my own simplest question too, and then you see if you have the same as me. If it's not the same as me, then yours is probably just as good, right? If it's the simplest one to you. All right. The goal is to find the simplest question. Pause the video now and do it. Okay, I'm going to suppose that you paused the video and you made your simplest question. I'm going to make the simplest one I can think of. Okay. Palladium, triphenylphosphine, tetra, right? And sodium ethoxide. Let's go back to blue. Is it going to give me? That's this one. Plus this one. Okay? That's it. That's the simplest one I can think of. CH3s. Alright? Now, maybe you didn't like putting Y on here, so maybe you put 3-methyls. Look at that. I know you don't like that. I know you don't like that, but look at, here's my methyl group. Here's another methyl group. And here's my 2 methyls. Now this is too simple to be understandable because they just look like lines, and you don't have enough features on here to remember that this is organic chemistry. It just looks like a line, right? Now if I'd have done something like that, you would have remembered that I was doing line bond structures, okay? So either way, here's 2, I would say simplest. The one below is probably, whoa. Oh, plus all that crap, right? Gobbledygook. So the one below is probably too simple to be considered easy. Your goal is to find the easiest possible question. Oh, and look, I traded this up a little bit, and I even didn't put sodium hydroxide to help myself remember. Sometimes bases show up like that, right? So when you're practicing, practice like I'm practicing. Make out the simplest possible reaction. Shift things up a little bit or look them up. Find the page number. I'm going to find the page number right now. I'm going to go get my book. You need to find the page number that's on, and that'll help you remember it. Be right back. You probably think I'm joking, don't you? You probably think I'm doing theater here, but I'm not. Really? Oh, chapter 28's not in my book. I forgot. So I got to go here to my computer. Well, I don't know where this is even. Chapter 28. It's on here somewhere. Let's go quick access. Uh-oh. Oh no. If I stop now, you're gonna think I gave up. I'm not giving up. Let's go to downloads. I'm not stopping. I'm gonna find this. Just what you should do, right? I've got some tenacity here, even though I'm aware that I may be losing my audience. But I'm talking to organic chemistry students who are tenacious people. And I'm gonna come. I got it in an email. That's the way I got it. And no, I'm gonna go look for it online. Same place you would find it. Here. For some reason D2L is not working right now. Please, D2L. Please, D2L, look. Maybe it's my computer. Okay, that's not working. Malia. Looking for an email I got from AJ Malia. Got it just the other day. Wow, I can't believe I'm putting this on YouTube. Fortunately, nobody cares, I think. There you go. There you go. Okay, save. Save this in Documents. See Windows 2212. Save. Okay. All right. I know it's very tacky, but I am honestly demonstrating what you ought to do. You ought to keep going. Chapter 28. Still looking for the page number. What was I looking for? Yeah, the page number where those details are. Yep. You got to do it. Page number where those details are. So it was in section 6. That looks like it right there, doesn't it? Yep, 28.6, right? Okay, so there's the details maybe for the first time. Let's go back. Oh, yeah, it is. Okay, so there's 28.6. Here's the details. First mention is on page 21 of the PDF. So I'm going to go back here. Shift F5. Okay, watch this. Oh, I was going actually not there. I was on the I want to keep that. I was on here when I said page 21 of PDF. That's the first place I saw that. I can go back and review it now when I care to. All right, please follow my example. Consider it. I know it may not be a convincing demonstration, but it's a good one. Page 21 is where I got that. I'll go back and look at it again later if I forget. All right, and the third or fourth time I look at it, it's going to be so easy I won't need to look anymore. All right, so let's move on. Those are my examples of what I would say are the, where am I? Easiest. Okay. Now let's go with the next easiest. Let's go with something a little more complicated. Let me get rid of this. And I'm going to say, okay, so the next easiest that is, or almost easiest. I'm going to add one layer of complexity on here. And this is likely to be different than yours, right? Because you're going to pause the video now and add one layer of complexity. Make it a little more complicated. And don't copy it out of the book. It's a waste. That's passive, right? Right now you're thinking in your mind, what makes this a little more complicated? Okay, I'm going to suppose that you did pause the video, and I'm going to write this out now. First thing I'm going to do is write a boron 3. And then, my favorite halogen's a bromine, but I used that last time. So I'm going to add an iodine this time. And I'm going to put another alkyl or aryl or vinyl on here, okay? So what are you going to do? I'm going to say, this time I'm going to put an ethyl group on here. And I'm going to leave these as Y's. And I'll look up Y again in a minute to see what Klein suggests that we put on there for Y. And for this one, you know what I'm going to do? I'm going to put a vinyl group on here. Okay? And I'm going to make it, I'm doing more than one layer of complexity, but I'm going to make this, looks like this is an E, right? Or a trans double bond. You see that? Okay. So now I've got my, and I'm gonna treat this with, and I've just done this recently, so I've got the, oops, I'm gonna go Z. I'm gonna put this in red. Palladium, PPH3, 4, and sodium methoxide. And I just did this, so remember this is on page 21 of the PDF. Right? And go back to blue. This is how I memorize, right? I keep writing those details down and think about it. Now I'm going to do this. I'm going to go to, let's go to, where's my yellow on here? Why don't I have yellow? It's weird, isn't it? I'm going to go to green. There's my R group. There's my other R group. Okay? And I'm going to put them here. In here, right? I mean, I see yellow there, but all right, let's go. Now, my first R group, I'm going to do this to make it easy for myself. Boom, that's this one. Number 1, number 1. And the other one, I got to turn this one upside down, so this is going to be a little difficult. But I can see that it's trans, right? I'm going to call this carbon 1, 2, and that's going to be bonded to carbon 3 and 4, right? You see, that's my new bond right there. And so 2, oops, whoa, I almost missed a carbon. 1, 2, 3. Oh, wow, look at that. It's so easy to do. 4 and 5. 1, 2, 3, and 3 is bonded to the new guy, right? And the new guy is 4. That's the new guy right there, 4. So here's, and I turn this one up. This is 5. And that's 4, 4 is bonded to 3, right? And 3, and so it looks like the new guy is trans to 1. That's it, right there. 2 and 1. Where that bond is E, or trans. Okay. All right, so there it is. I added a couple layers of complexity there, more than one. That's not quite the next easiest, but I would say that's still relatively easy. I don't know. Probably you're unfamiliar with that right now, and you feel beat down when I say easy. All right, skip easy. Don't worry about easy. Doable. This is accessible. There are not very many atoms on here, and that makes it accessible. Okay? Now, I think might be a good time for me to demonstrate one that I think is difficult. Really, you should practice this a few more times before you do the difficult. And if you're struggling in your spirit, and I sense that there are some students in this class that are struggling in their spirit, maybe you should skip this part, because you can't progress if you think you can't progress. All right, that's a little too much philosophy, isn't it? Let's go on. I'm going to do one that's harder. I'm going to go, let's see, what would make it harder? How about intramolecular? And I'm not even sure this is possible. So I'm going to build it, then I'm going to go to the PDF and see if, this is going to be a long video, I can tell. I'm going to build it, and then I'm going to go to the video, to the PDF and see if that's possible. I have a feeling it is. All right, so intramolecular, and what that means is that this guy is on the same structure. Watch this. Is on the same structure as this guy. Intramolecular. Is that possible? We'll have to go back and look in the PDF and see if it is. But let's for now, let's suppose it is, all right? So I got my boron and my X, and let's make the simplest intramolecular one that's possible. CH2. CH2, right? You see that? Here's a CH2. Here's a CH2, here's a CH2, and here's a CH2, right? We'll add these two guys together. And I'm getting really good at these reagents. PD, PPH3, 4, and I'm going to do a different reagent this time. I'm going to say sodium hydroxide, because it said a strong base. We've already seen there's some variation there, right? Okay, now what's this going to give me? Well, I can see I drew this out to make it easy for myself, right? That's the new that's the new bond, and that's the new bond, right? So I'm just going to go. I'm going to call this carbon 1, 2, 3, 4, 5, and 6. Oh my goodness, this is too easy, right? 1 is carbon here. 1, 2, 3. 4, 5, and 6. And there's my new bond. Boom. 6, 2, 3, 4, 5. Wow, this is the same thing as where's my new bond? Since these all bonds all look the same, it's not fair to say, but right, if I'm numbering them, that's my new bond. Wow. Oh, plus I got all this other stuff over here, right? Remember all that other stuff I told you to forget? Forget it. All right, look at that. Intramolecular. I'm going to go to the PDF. You know what? I'm not going to go to the PDF. This is just soaking up time in the video. You go to the PDF. I'll do it after I'm done with this video. And I'm going to see, when I was making these things, could I make a boron compound that had a halogen on the end? I should have let you figure it out. That was the question. Can I make something like that? If I can, I have an intramolecular reaction. Wow. And let's make it harder yet. it's 6 carbons long. Let's rearrange. Let's shift it so it looks different. 1, 2, 3, 4, 5, 6. Wow, look at that. That's nasty, isn't it? PH3, 4, and sodium methoxide. Wow, that's just mean. It's going to give us what? It's going to give us that. Right? How would you know? You'd recognize you've got a boron, you've got a halogen. Oh, whoa, this is, folks, look at. This is Suzuki. It's a coupling reaction. I find my boron, my halide R group. Here's my other one, and I make a new bond. New bond. All right. Okay, folks. So that's a couple examples of how to study organic chemistry. I hope that's helpful. Let's move on. I think I'm just about worn myself out. So bonds that can be made via the Still coupling and or Suzuki coupling. You see, I've really just very much talked over this stuff just now. So you see, I've got a new bond here. It's either sorry, means I'm done studying. I'm going to finish this video and then I'm going to take a break and go wash some dishes. SP3, I can make an SP3 to an SP2, right? You see that? There's an SP3. This is an alkyl group. You should go through and name all these things. What kind of group is this? That's an aryl group. And I don't mean name them. I mean say what groups they belong in, right? Here's an aryl, right? The reason I don't want you to name it is because this would give the same reaction as if I had a methyl group on there. Same thing, right? All right, you need to think in terms of groupings and trends. How do these things group, and how are they similar? And that's how you can learn to do this stuff. I think I'm done with this section. Let me look. Let me look at this next slide here. Yeah, we've done this already. See, stereospecific. These are stereospecific. In other words, I just clip this off. If this is E over here, and I clip this off, and this is Z, then when I put them together, there's my new bond. This is still going to be my Z, right? You see that? And we don't care about this stuff. And I think this is it. I'm going to look at the next slide here. It's the same stuff. All we're doing is saying what these things are. Okay. This looks like we're making these over double bonds. Yeah, don't even worry about this stuff. And I realize the objective says, one of the objectives is how to make the stuff. Let's assume we're going to make it. Assume for the sake of the next quiz that we're simply going to, don't even worry about this stuff. If you're not in my class and if you're in someone else's class, then yeah, worry about this stuff. But it's incidental. It's not the point. We would look this up. If we were going to make this stuff, we would look it up. This is not the clever part. All right? And we definitely don't need the mechanism. Okay, interesting, yes, we don't need it. And that's it. Hope this video has been helpful.